In this video, we're going to be graphing a quadratic equation and then comparing it with the parent function. So we're going to be graphing, comparing with the parent function. So here we have our table, and we're going to be using the numbers -2, -1, 0, 1, and 2 to plug into our function y equals 3 times x squared. So we're going to plug each of our x values into our x in our equation. So we have 3 times -2 squared. Now what that looks like, it's 3 times -2 squared. You need to make sure you have the parentheses because without them, you're going to get a different answer. So if we take that and we plug it in, that's going to give us a value of 12. If we plug in a -1 to the x's place, that's going to give us a value of 3. If we plug in a 0, that's going to give us a 0. A 3 will give us a 3, and a 2 will give us a 12. So we're going to go ahead and plot those points and graph our line. And so this is what our equation y equals 3x squared looks like. So we've done our first part. We've graphed our equation. But now we want to compare it with our parent function. Recall that our parent function for a quadratic equation is, or quadratic function, is y equals x squared. So if we plot our y equals x squared function, we see that our y graph, or our current graph, our green graph, is skinnier. That's what we call a vertical stretch by 3. So that means that our graph is skinnier than our parent function. So now we've graphed it, and we've also compared it to our parent function. We know that it's a stretch by 3 because of the 3 in our equation here. So because of that 3, that's how we know that's a vertical stretch by 3 as well. Let's do another example. In this example, we'll be graphing y equals 1/3 x squared. So we'll still fill out our table with a -2, -1, 0, 1, and 2. And we're going to plug that in, just like we did before. So we're going to have 1/3 times -2 quantity squared. And when we plug that in, that's going to give us a 4/3. Now when we go to graph that, it's going to be easier if we think about it as a 1 and 1/3. When we plug in a -1, that's going to give us a value of 1/3. And that's something that you can plug into your calculator to make sure that that's what you get. So 1/3, parentheses, -1, close parentheses, squared. If we plug in a 0, we're going to get 0. A 1 gives us 1/3, and a 2 gives us 4/3, which again is 1 and 1/3. So we'll graph our function y equals 1/3 x squared, but we still need to compare it to our parent function. So when we graph our parent function, we see that our y equals 1/3 x squared is much wider than our parent function. And so we call that a vertical shrink, because we're taking it and we're shrinking that, meaning we're pulling it down. So it's opening up and making it wider. And so this is a vertical shrink by a factor of 1/3. And I get the 1/3 from my equation right here. And that is how you can graph functions and then compare them to your parent function.